This is video number 1 on the topic motion in a straight line. Motion means position of an object is changing. For example, let me consider this block of mass m. Let the location of this object be here at time t0. At a later time t1, let it move here, for example. And a still later time t2, let it move here. So here the position of this block of mass m is changing with time. So such a thing is called motion. We can say the block is in motion. Straight line, given 2 points, 1 and 2. There are multiple ways one can go from point 1 to point 2. For example, this is one way, second way, third, fourth. But there is only one unique way, which is the shortest path. That is the straight path between the 2 points. So the shortest path the length of the path can be measured. For all the paths, this path will have the shortest length. So this is straight line. So straight line can be defined as the shortest path between the 2 points. There is one more way we can define this straight line. Suppose I have a light source here, which is giving out light in all directions. One particular light ray will go like this and reach this point 2. Other light rays will not reach that point. So the light ray which connects the 2 points 1 and 2 is the straight line. So light takes the path which takes the minimum time, which is same as the path which has got the shortest distance. So straight line is also defined as the path taken by the light between the 2 points 1 and 2. Timestamps are given in the description box. You can watch parts of video if you are running short of time. In this video, I will talk about how the position of a body is represented using coordinate system and also using position vector. Motion is position of an object changing. How is the straight line defined? Distance and displacement. How is it defined? I will discuss some 6 conceptual questions. Finally, I will summarize this video. Straight line is the shortest path between 2 points. For example, these 2 points 1 and 2. So this is the shortest path between them. So this is a straight line which is between these 2 points there can be multiple ways we can reach this point 2, but one particular way is the shortest path, which is a straight line. And also if you have a light source here which is emitting light in all directions, this one particular light ray will reach this point. So this path taken by this light is the straight line. Light will take the shortest time path that will correspond to the shortest path between the 2 points. So straight line can also be defined as the path of light between the 2 points. A body is set in motion if its position keeps changing with time. For example, let this some body be here at time t1, at a later time t2. let it be here, T3, T4, and at time T5 it has reached here. So this is a body moving in this plane. But from here to here, let be the body be here at time T1, let it be here at time T2, and T5 let it reach here. So this motion is straight line motion. This motion is motion in plane, it's not a straight line, it's in a curve, but all the positions of this object are in this plane of this board. So this motion in the plane. So if you consider body as a system, then input is force and output is motion. For example, let me take this block of mass M lying on a say surface of a table. For this mass to move, I have to give a force to it. So if force is applied like this, we start moving in this direction. So we can consider force as input and the motion as output. And once it starts moving, the position of this object, say at time t1 will come here. Suppose this is the initial time t, and at t2 will come here. And you can also turn back, and let's say at time t3, just come here. It's possible because it's going like this, stopping, turning back, and coming like this here. So how the position of this object is changing? So x as a function of time, and also how fast it is moving. Whether it's going slowly or going fast, that is explained by this velocity v of t. And also, is it going with a uniform velocity or the velocities keep on increasing? That is acceleration. For example, from going from here to here, I can go with the speed of 1 meter per second. Then I can increase the speed to 2 meters per second, and then decrease the speed to 0.5 meter per second, and then 0 meter per second. Because it's turning back. While turning back, the speed will be 0. And after that, when it reaches here, it's moving in this direction. Let's say minus 1 meter per second. Minus because it's moving in the opposite direction. One direction is positive, other direction is negative. So here now it's moving in this direction. Here is the opposite direction. So if I take that as positive, this direction is negative. So how the position is changing, how fast it is moving, and how the velocity is changing with time. That is acceleration. So all these things will describe how it is moving. So kinematics is study of describing motion, which is how these quantities vary with time and the relationship between them. So body can be considered different types. First, we can assume that body is like a particle, like a point mass. In the sense, we can assume the body has got some mass, but it can be represented like this. So this is valid when the size of this object is small compared to other dimensions of the problem. There is also one more case where the body can be considered as a particle. For example, the same block moving on a surface. It's moving like this. All the parts of this block, so this point or this small region of this block will move towards right with velocity. This also move towards right. So all the parts of this block will have the same velocity towards right. So in this case, you can consider that the full mass is concentrated in the middle. Will have this velocity, and the full mass is concentrated at this point. So this also can be considered as a particle. But suppose I have a gas, then different molecules will have different velocities in different directions. So in this case, I cannot concentrate the full mass at one point. So here I have to consider this as made of multiple particles or a system of particles. Rigid body, suppose example is I have a disk, circular disk, and this is a vertical axis. And suppose the disk is rotating. Here in this case, this part of the disk has a velocity like this, and this will have a larger velocity, and this part of the disk will move like this. So different parts of the disk are moving different velocities. So here also I cannot concentrate the full mass at a single point like this one, and it considers a particle mass. So, and one more thing is here, the distance between any two parts of the disk is fixed. It will not change, it cannot be compressed or expanded. So that is rigid body. But in the case of gas, the molecules can go close to each other or also it can move far away. So this is an example of rigid body. Similarly, we can classify motion. One way of classifying motion is translation motion, rotation motion, and the combination of the two. Translation motion is like this block moving this direction. This can also happen along a slope surface, inclined surface. So in both these cases, all the parts of this object will have the same velocity. Here it's inclined, but all the parts of this mass will have the same velocity. So this is translation motion. So sliding block either on a horizontal surface or on an inclined surface. Next type of motion is rotational motion. Example, say I have a sphere of mass m and attach a string to it, and this point is fixed. Like I use a nail to fix this point. And say this is a horizontal table and the table is smooth. So if you give a push to this mass, the mass will go like this in a circle. So this is an example of a rotational motion. Another example is sun is here and earth is at a distance. So earth is moving around the sun in a circular path. So this is also an example of rotational motion. Another example is we have a disk, circular disk, and a vertical axis, and rotate this disk with some speed. So this is also an example of a rotational motion. Third type is combination of the first two. So how to combine them? So there is one practical example where this combination is there. So this is a car. So this is a wheel. Okay. So the car is moving towards right. So all the parts of this wheel will have a motion towards the right. So this is moving at Vt. Will have the velocity Vt. But in addition to moving towards the right, the wheel is also rotating about its axis. It's also rotating. It's an angular speed omega. So in addition to that, you have a speed which is omega r tangential with the axis. Draw a circle touching that point. So that tangent to that circle will give the direction of omega r. So here the omega r will be like this. Here omega r is perpendicular. So all parts of this wheel of a moving car will have two velocities. One is the translational velocity, which is same for all the parts, and the rotational velocity, which is omega r, is a function of r, and is be tangential to the circle about the axis of the wheel. So this is combination of rotation and translation motion. Another way of classifying motion, it's 1D, 2D, or 3D. 1D motion is like this. It's moving in a straight line. And also it can turn back and come like this. Assume the same line, just for visualizing I'm drawing a little bit gap. Again it can turn back and go like this. So all these things happening in one line. Just for sake of explaining, draw a little bit gap. So this is a straight line motion. 2D motion, it's like this. So here it's not along the line, it's along the curve. So all the points, any point here, will have two coordinates, x comma y, x1, y. Here, x2, y2. But here we can say this point has got coordinates x1, this point has got coordinates x2. But y is same for all the points, which can be considered as 0. So here the motion of this object can be explained by saying how the x is changing with time. But here you have to mention both x and y. Another example of circular motion is 2D motion is circular motion, where the object is moving in a circle. So here both x and y are changing. X axis we can take it as horizontal axis in this direction, and y axis is vertical axis. And 3D motion means in addition to this moving here, say the object is moving here, but it can also come out of the plane of the board. Now it becomes 3D motion because I have to mention how far it is from this board. That is z coordinate. We put a statement z coordinate is board. One example of 3D motion is helical motion. Helical motion will be like this. So it's like a circle is coming out of the plane of the board. One way to understand this helical motion is assume this is a circular ring. So you cut this ring at this point, and one end of the ring you fix to this board. Other end you just pull it out. So that will become helix because some parts of the ring are coming out of the board. So you need the z coordinate to specify the points of this motion. That is helical motion. Another type of motion is oscillatory motion. So I have a pendulum like this, a mass end, and a string attached to a fixed support. So I pull this mass on one side and then leave it. So the mass will go like this. You go here like this, and then come back the same line, but I'm drawing it separately to visualize. And then again it will repeat. So starting from here, say point 1, and coming back here, point 2. That is one complete period. After it just keep on repeating. So this oscillatory motion will go like this. And then it will keep on repeating. Another example of oscillatory motion is spring. A mass is attached. This is a fixed support. So it is at rest. From this rest position, pull this mass downwards to this direction and leave it. So the mass will go back, because the stretched string will pull it back. But after it reaches it, not stop because it will got some velocity. Keep on going up. When it's going up, the spring will get compressed, so we'll try to slow it down. So here the velocity will become 0 and will turn back. And reach here. Again, when it reaches it, will not have the. When it reaches it, the stretched string will pull it back. So it will again go back. So this we can consider as point number 1, and this is point number 2. So this is one period. After that, will keep on repeating, similar to this one. So here the spring, the mass will go like this, go like this, go like this, go like this. So it will keep on oscillating. So this is oscillatory motion. It's a periodic motion. So any motion which is not oscillatory is non-oscillatory. For example, projectile motion, where the mass is thrown from the Earth's surface to the Earth's surface. So it will go like this. So there is no repetition here. Just one time, it will hit and stop. So this is non-oscillatory motion. So as mentioned earlier, if the size of the body is much smaller compared to the distance it moves, it can be treated as point object. Another condition where you can consider as point object is all the parts of the body or object is moving in the same velocity. So full mass can be considered as a point at the middle. For example, this block moving horizontally. So all the points of this block will have the same velocity. So the full mass can be considered as the total mass in the middle. In that case also we can consider this body as a point object. So position of the object is same as position of the point. So we should know how to specify the position of a point. Suppose the body is moving along a line. This is my x-axis. Suppose this mass starting from here, it's going like this. You can also turn back and go like this. So how to specify the position of this one? So this x-axis will have a origin. Let the origin be here. Suppose this is time t0 and time t1 it is here and t2 is here. And suppose this is say 0.5 meter and from here to here this much we say 1 meter and from here to here say 1.2 meter. 0.5 meter is this one from here to here and 1 meter is from here to here and 1.1 meter is 1.2 meters from here to here. So x coordinate of the object at time t0 is 0.5 meter. At time t1 x coordinate of the object is 1.5 meter and at time t2 the x coordinate of the object is 2.7. 1.5 2.7 1.5 is 1.2 2.7 meter. So the position of this object can be specified by mentioning this x coordinate. So if it remains along the line, we just have to mention one coordinate. But if you consider a body moving along a plane, not along the line, for example, this mass at time t0 is here, t1 it is here, but t2 has gone here. So in this case, just by x coordinate, this is the origin of the x-axis, this is x-axis. So just by mentioning the x coordinate, we cannot specify the position of this one. We need one more axis, vertical axis, which is y-axis. So the position of this point is given as x0, which is this distance, and y coordinate is 0. And this position of this object is, of this position is x1 and y coordinate is 0. But here the position is, so this much is x2, so it will be x2, comma y2. Y2 is this much distance. This is y2 from here to here. So when the object is not restricted to a line, it's moving in a plane, we need two coordinates to mention the position of this object. But suppose after the body reaching here at time t2, it has come out of this plane of the board at t, it is here. So to measure of this position, we need this much distance. So that is z coordinate. So z axis can be defined like this, out of the plane of the board and coming out. So it's z axis like this. So to mention the position of the object here, we have to mention both x3, y3 and z3, z coordinate. So point along the line, we need only one coordinate. In a plane, if it's moving in a plane, we need two coordinates. If it's moving out of the plane also, then we need three coordinates. So we live in a 3D world, so we don't need more than three coordinates. Any point in this space can be specified by x, y and z coordinate. So the object here is moving from point A to point B, O to point A. The object here is moving from point origin to point A and then to point B. So here it's moving along the line. So if you mention the x coordinate, the position of the object is fixed. But here the object is moving in a plane, so we need to specify both x and y. But here the object is moving from O. This point is out of the plane. It's not in the plane of the board. It's somewhere here. So we need to specify both x, y, all the three coordinates x, y, and z. There is one more way. Instead of using x, y, and z, position of object can be mentioned. Suppose the object is here. So if we specify the distance of this object from the origin, that is r, and also the direction in which you have to go. That way also the position of a point can be specified. Any point, what is the distance of the point from this origin, and also the direction of that point. So if I know the direction of the point, I'll go in that direction to that much distance to reach that point. So position of a point can also be represented by position vector, which is how far you have to go from the origin, and also in what direction. This will learn in detail later. In 1D problem, all the parameters are function of one variable only. For example, x, straight in motion, also known as rectilinear motion, is 1D motion. So we saw the body moving like this at time t1 here, time t0 here, at time t2 here. We can consider this as x-axis, and this is a 1D motion. But suppose it's moving like this, it's moving like this. At time t0 is here, but t1 is here, and t2 is here. So this motion, is it a straight line motion? It is straight line motion, but it's along a different axis. So we can consider this axis as x1 axis. So straight line does not mean it should be along only x-axis. It can be in any line on this plane. And also instead of moving like this, it can also move like this. So it's a line in space. This is a line along the x-axis. This is a line in the plane of this board, which is xy plane. And also it can be in any general direction in the space. So straight line motion does not mean it should be along the x-axis. It can be any direction, but should be along the line. So here the body is moving from point A to point. Here the body is moving from point O to point A in a straight line. In the first case, moving along the x-axis. So it's a straight line motion along the x-axis. Here it's moving in a line in this plane, but in some other direction, not along the x-axis. So this was the straight line motion. We just have to consider this as a new x-axis or x1 axis. So here this line is in the space. It's not in the plane of this board. So here we can consider this direction as x1 direction. So straight line does not mean it should be along the x-axis. It can be in either direction. It can also be space, but should be along the line. It should move like this one. It cannot go and turn back. That's not a straight line. It should go straight, but the line can be anywhere in space. Distance is the path being covered moving from one point to another point. For example, I'm moving from the initial point to a final point. I can go straight or also I can go like this. So I'm going this curved path. So whatever is the length of this path, that is the distance covered. But displacement is how far the final point from the initial point. It does not depend on the path. It just gives the information how far the final point is from the initial point. So displacement is from this distance. So this is distance, the path length, actual path, but displacement just bothers about the final point, how far it is from the initial point. So this is displacement. Displacement is changing position when moving from one point to another. It's a measure of how far the final point is from the initial point. Obviously, this displacement is less than the distance because it's a straight line. So this length will be less than the distance. For example, here the object is moving from 1, 2, 3, 4, 5. So within the time interval 1 and 3, this is the distance covered and this displacement. Displacement is how far this point 3 is from point 1. So this is a straight distance. So displacement is this one and distance between the time interval T1 and T3 is this one. So obviously displacement is less than distance, magnitude. Always. I'll discuss some questions. This is the first one. Draw north, south, east and west directions. Does it form a plane? How many lines define a plane? Usually the north direction is upwards, south is down, and east is right, and west is left. One way to remember this, visualize India map. Kashmir is in the north, Kanyakumari south, east we have West Bengal, and in the west Gujarat. So if you remember India map, you can remember the direction. So two lines will define a plane. For example, this line, these two lines are drawn in this plane on this board. So this defines the plane on this board. But these two directions, the angle between them is 90 degrees. It's not necessary for the two lines to be perpendicular. Suppose I can have a line like this and second line like this with some angle. So these two lines also define this plane. But suppose I have only one line that will not define a plane. For example, this one line can lie in this plane. It can also lie in this plane. It can also lie in this plane. So this line can lie in infinite planes. But suppose I give a second line here and say the plane should contain both the lines, then the plane can also only be like this. So that will define the plane. Similarly, I can also have two lines in space like this. So this is the one which the plane defined by the two lines. Suppose I have only one line, then I can have infinite planes that will have this line. But suppose I have a second line, there is only one plane which will touch these two lines. So once I have two lines, plane is fixed. So two lines define a plane. Similar to 2D, 2 points will define a line. Suppose I have 2 points, there is only one line which is joining these two. So once I fix 2 points, line is fixed. But suppose I have only 1 point, then there are infinite lines which will contain this point. This one line, second line, third line, fourth line, like this. But suppose I say the line has to pass through this second point here, then there is only one line. So 2 points define a line. Similarly, 2 lines define a plane. Second question, the car is moving towards east, the distance 8 kilometers. It stops and changes direction and moves west 6 kilometers. Find distance covered and displacement. So east is towards right, starting point say O, it's moving towards right, distance of 8 kilometers. It stops and changes direction and moves towards west, that is east is this one, west is in the left. So it's turning back and traveling a distance of 6 kilometers. So this is the initial point I, final point F. So distance covered is its total path length, that is 14 kilometers. 8 plus 6, 14. And displacement is how far the final point is from the initial point. That is this much. That is 2 kilometers. So displacement is 2 kilometers. Next question. The car is moving towards east, distance of 8 kilometers. It stops in this direction and move towards north 6 kilometers. Find the distance and displacement. So it's moving towards east. This is the starting point O. Towards east 8 kilometers. North is up and then moves north 6 kilometers. So from here it goes up 6 kilometers. So initial point is here, final point is this one. So distance is the path, total path length, 8 plus 6, 14 kilometers. Displacement is how far the final point is from the initial point. Final position from the initial, this straight distance. So that will be 10 kilometers. This you can get from Pythagoras theorem, 90 degrees. So 8 square plus 6 square is 10 square. Another way to remember this thing is standard right angle triangle. 4, 3, hypotenuse will be 5 because 3 square plus 4 square is 5 square. So this triangle magnified twice will become 8, 6, 10. Okay, so this is a magnified triangle. So 3, 4, 5 is a right angle triangle. Any magnification or compression of it is also a right angle triangle because magnifying will not change the angle, still be a right angle triangle. So if you multiply this thing by 2, I'll get another right angle triangle of size 8, 6 and 10. So we can avoid this calculation if you remember this one. Next question. Fuel spent by the car depends on distance or displacement. Obviously distance. Suppose I'm moving from this initial point to final point like this. So this is the distance and the displacement is this straight path connecting these two. So since the car is moving on this path only, so the fuel will depend on the distance, not on the displacement. So distance has some meaning. Next question. Give an example of motion where the distance and displacement are same. Let me consider simple motion, say starting from here, initial point, going like this, and then stopping. So here in this case, it's going straight, distance and displacement are same. But suppose I complicate this one, I start from here, go like this, and then stop, and then turn back, and then go like this and reach this final point. Here distance is from here to here, and then from here to here, and then from here to here, and then from here to here. So it will be more than displacement is straight, distance will be initial final point. So here distance is greater than displacement. Here both are equal. So this is the only case where the distance and displacement will be same. It's a straight motion without change in the direction. Here there is change in direction because stopping and turning back. So this is the only case where distance and displacement will be same. Next question. Give an example of motion where distance has some value but displacement is 0. So a motion like this, it's going like this. You can also turn back and go like this. Okay. But the thing is, it has to come back to this initial point. Initial point and final point are same. In this case, displacement is how far the final points from the initial point. Both are same. So displacement is 0. But distance is distance. Another example is suppose I throw this mass, it will go up and come down at the same point. So this is the Earth's surface. From the Earth, see I am throwing a ball straight, vertically, not at an angle. I am throwing this ball straight. The speed will keep on decreasing because the Earth is pulling it down. So at this point the velocity becomes 0 and it will turn back and reach this ground. So here, this is the initial point and this is the final point. So here the displacement is 0, but distance is whatever this height, say h. Distance is 2h. Displacement is 0. So steady motion where initial and final points are same, the displacement is 0, but distance is the path length, which is not 0. To summarize, straight in is the shortest path between 2 points. It's also path taken by the light, because light will take the path of least time. A body can be modeled either as a particle or a system of particles like gas or a rigid body, depending on the problem we are trying to solve. Motion can be broadly classified as transitional, rotational, or combination of both. Another way of classifying is 1D, 2D, or 3D. 3D means depends on both all the three space variables x, y, and z. 1D only x, 2D x and y. Motion can also be oscillating motion, like example simple pendulum, or non-oscillating motion, example projectile motion. Distance traveled by a body is from moving from one point to another is the path length. Displacement is measured of how far the final position is from the initial position. You can ask doubts in the comment section.